Cosmic collisions, impacts and consequences in the universe. Title: Cosmic collisions, impacts and consequences in the universe. Introduction. Cosmic collisions, the breathtaking encounters that occur between celestial bodies in the vast expanse of the universe, have captivated the human imagination since time immemorial. From the smallest asteroids to the largest galaxies, these dramatic collisions shape the cosmos and leave lasting consequences in their wake. In this article, we will explore the various types of cosmic collisions, their causes, and the profound effects they have on our universe. 1. Stellar collisions. At the heart of our universe lie countless stars, and occasionally, their paths converge with cataclysmic results. Binary star systems, where two stars orbit around each other, are particularly prone to stellar collisions. These violent encounters can lead to the birth of new stars or, in some cases, the complete annihilation of both objects involved. The sheer force unleashed during a stellar collision can release an enormous amount of energy, resulting in the emission of powerful bursts of radiation that can be detected across vast distances. 2. Planetary collisions. Within our own solar system, planetary collisions have left indelible marks on the surfaces of many celestial bodies. The most prominent example is the Moon, which is believed to have been formed as a result of a colossal impact between a Mars-sized protoplanet and the early Earth. This colossal collision ejected debris into space, eventually coalescing to form our Moon. Such planetary collisions have been instrumental in shaping the architecture of our solar system and influencing the conditions necessary for the existence of life. 3. Asteroid and comet impacts. On a smaller scale, the collision of asteroids and comets with planets has played a pivotal role in shaping the geology and evolution of celestial bodies. The impact of a large asteroid or comet can release immense energy, creating enormous craters and causing widespread destruction. The most famous example of this is the Chicxulub impact around 66 million years ago, which is widely believed to have triggered the mass extinction event that wiped out the dinosaurs. These impacts not only have the potential to reshape the landscape, but can also alter the planet's climate, with long-lasting effects on life forms inhabiting the impacted region. 4. Galactic collisions. Beyond individual stars and planets, entire galaxies engage in epic collisions that can reshape the cosmic landscape on a mind-boggling scale. Galaxies, with their vast concentrations of stars, gas, and dust, can merge and interact, as the gravitational forces between them cause them to approach each other. These galactic collisions unleash enormous energy, triggering the formation of new stars and altering the structure and content of the galaxies involved. Such events provide astronomers with invaluable insights into the processes that shape galaxy formation and evolution. 5. Consequences and implications. The consequences of cosmic collisions extend well beyond the immediate destruction and creation of celestial bodies. These encounters disperse matter and energy throughout space, enriching and fertilizing the universe with heavy elements crucial for the formation of new stars and planets. Moreover, cosmic collisions serve as a driving force behind the exploration and advancement of our understanding of the universe. By studying the aftermath of these collisions, astronomers can unravel the mysteries of celestial mechanics, planetary formation, and the evolution of galaxies. Additionally, They provide valuable insights into the properties of matter and energy, shedding light on fundamental questions about the origins of the universe and its ultimate fate. Continuing from the previous content. 6. Detecting and studying cosmic collisions. Detecting and studying cosmic collisions present unique challenges for astronomers. These events can occur over great distances and timescales, making direct observations difficult. However, advancements in technology and scientific instruments have allowed scientists to overcome these obstacles and gain valuable insights into these remarkable phenomena. One key method used to study cosmic collisions is through the observation of electromagnetic radiation. When celestial bodies collide, they release immense amounts of energy, causing the emission of various forms of radiation, such as light, radio waves, and X-rays. Astronomers utilize telescopes and detectors designed to capture and analyze this radiation to study the effects and consequences of cosmic collisions. Observatories both on Earth and in space are used to collect data from these collisions, enabling scientists to unravel the mysteries of the universe. Additionally, scientists employ computer simulations and modeling to investigate cosmic collisions. By inputting known data and physical principles into complex computer algorithms, researchers can recreate and visualize the outcomes of different collision scenarios. These simulations allow scientists to test theories, make predictions, and gain a deeper understanding of the processes involved in cosmic collisions. 7. Future discoveries and exploration. The field of cosmic collisions is constantly evolving as new discoveries and observations continue to be made. Ongoing research and technological advancements hold the promise of revealing even more about the dynamics and consequences of these cosmic encounters. In the coming years, astronomers hope to gain further insights into stellar collisions by studying phenomena such as gamma-ray bursts and gravitational waves. These rare and powerful events are thought to be associated with stellar mergers and can provide crucial information about the behavior and aftermath of these collisions. Furthermore, upcoming space missions and telescopes, such as the James Webb Space Telescope, will offer unprecedented opportunities to study cosmic collisions. The exploration of cosmic collisions also extends beyond our own galaxy. Scientists are increasingly focusing their attention on colliding galaxies and galaxy clusters in the distant universe. By studying these colossal collisions, researchers hope to unravel the mysteries of galactic evolution, dark matter, and the processes that shape the large-scale structure of the cosmos. 8. Implications for our understanding of the universe. The study of cosmic collisions has profound implications for our understanding of the universe as a whole. By peering into the aftermath of these events, scientists gain critical insights into fundamental processes that have shaped and continue to shape the cosmos. One such implication is the role of cosmic collisions in the distribution and abundance of elements in the universe. Many heavy elements, including gold and platinum, are formed during the intense conditions present in supernova explosions and stellar collisions. These elements are then dispersed into space, becoming the building blocks for future star and planet formation. Understanding the origin and distribution of these elements is crucial for comprehending the origins of life and the potential for habitable environments in the universe.